Hello again. For the same problem, question 27 says the planner has also suggested a third option that could take into consideration the populations of the three cities. Describe a possible option that uses population information to find a site for the stadium. So there's a weighted population formula, but I cannot apply here. I cannot find this center in somewhere here. But my suggestion is to use the most crowded or population city, which is Raleigh, like more than 400,000 people lives there, and it's almost twice as Durham and maybe like 6, 7 times of Chapel Hill. So we can construct the stadium in Raleigh here. So we can use the local streets, and we don't need to build a new highways. Just we can resurface from Durham to Raleigh or Chapel Hill to Raleigh. So let's calculate this one. Um, Here I can just type from C to R, CR plus DR times just for resurfacing 50,000. Let's multiply 50,000. Okay. It's slightly more than $3 million, and of course we just check the price, the construction cost. I mean, we don't know the local streets will be enough or not, need to be reconstruct or resurfaced, but according to information the question, we just can say this is the cheapest way, like but we don't know how the traffic jam and the cost from different cities, people coming to the Raleigh from Durham or from Chapel Hill is gonna be we don't know it's cost effective or not. It's totally out of this problem. Okay, question 28 says create a different fourth option. Describe and explain how it compares to the other three options. Also, we can use median for building this stadium. We can find a site at the median. So how can we do that? It's we can use this midpoint. So let's find the midpoint of each side, and we can join them with opposite vertex, and the intersection is going to be our median. So this is median, or we just label it G because it's center of gravity. So P is our median. Now let's go and draw the lines. These line segments represent new construction highways. Okay, let's go here. Let's calculate these things. Okay, from let's make a parenthesis P C plus PD plus PR. Okay, total 42 miles, and this is new construction, so we are gonna pay $125,000 per mile. So it's 5,312,605 dollars. So it is not the cheapest one, but it's very close to the one which is in center, but slightly more than that, like $100,000. But it's not bad. This is the fourth option. According to first two, the circumcenter is more than 6 million. The one which is located at in center is like 5 million, like two. Let's see here. Yeah, it's something like that. Yes, this one, 5,200,000. So it's not bad, and this one is not cheaper. So, but this is another option. So we can have also another option. If we try, we can have ortho center. We can use ortho center, which is we do ortho center is, let's think it. Ortho center is not that one. Okay, okay. Perpendicular line to this, and perpendicular line to this, and so this one to this one. Okay. Now, this is my ortho center. Okay, let's hide this. And Q is ortho center, is a center of one type of center of a circle. So here we can also calculate. Let's draw the lines from C to Q, Q to D, and Q to R. And basically quick, let's calculate here. We are going to construct new highways. So QC plus QD, okay. QC plus QD plus QR. So totally 51 miles, and those are gonna be new highways. It's not gonna be cheaper, I think. Okay, it's 6,471,000 something. So it's the most expensive one. So that is the answer for the question 28. Yeah, this is the fourth or fifth option as we did, but they are not suggestible. We cannot suggest those, but these are technically an option. But here, we just find the cheapest version is to build in Raleigh, and it's almost half price of total cost according to this cheapest one, around like halfway. Okay.